Hey guys, back for day 3. This one took a lot longer and it was definitely a lot harder without mutability, but I'm glad that we've got it done. So pretty much in this question, you get given an input like this, and what happens is that pretty much any value that's adjacent to uh, a piece of grammar, for example, this asterisk, or a symbol I should say, is added to the score. So in this example here, 467 is next to this asterisk, 35 is next to this asterisk, but 114 is not next to anything. So, you'd add 467 to the score, add 35 to the score, you wouldn't add 114, and then, yeah, so pretty much in this example, the only values that would get excluded are 58 and 114 since they're not touching any, and this includes a diagonal. Let's look at the code. So it's quite long, and I'm sure there's a better way of doing it, but anyway. Pretty much what happens is that the first thing I wanted to do was I want to check which numbers are valid. And I did this by having this valid number array function, which pretty much goes through the list and it's pretty much like a nested for loop that checks every value. And if it isn't a full stop and it isn't a digit, we know it's a piece of grammar. So, for example, we go into the list, we come to this asterisk, we know it's not a full stop, and we know it's not a number, so we know it's a grammar, and therefore every value adjacent to it will mark as true in this this valid number array. So this valid number array pretty much represents if a number is true in any of this valid number arrays, that means that we're going to add it to the total. And then what we do is we're going to go through the input again, and this time what I've done is I pretty much made this function here, which is called numbers in a row. And this is just pretty much a bit of string passing that in this example, it would give us the values 467 and 114 in a list. Then I check the number of recurrences. This is pretty much an edge case I thought of where, which will come in later. So what happens is, so say that we find 467 one time, we'll look for the index of the first index of 467. So in this case, it'll be the index 0 is where we find 467. And then what we do is we loop through from the starting index to the ending index. And yeah, we add that number to our array. Yeah, and this number of occurrences is that if a value appears twice, so say there was 467 here and 467 later, when we're searching for the index of the second 467, we want to make sure that's also in a valid location. So yeah, I wrote this recursive function here to pretty much, it keeps checking the next index. So, we give it like, find the second occurrence of a string and it'll give us the first index of the second occurrence. And then, yeah, pretty much we just sum them all together. And that's our solution. Part 2. So in this one here, pretty much we want to find any asterisk, and this is asterisk only, not any piece of grammar. We want to find every asterisk that has exactly 2 numbers touching it. And then we multiply those 2 numbers together and add them all to the score. So in this case, we go to this asterisk, you can see that it has exactly 2 numbers touching it, so we multiply them together, which will equal this number, 16,345, and we add it to our score. We go to this asterisk here, you can see it only has a single number touching it. Then we go to this asterisk here, we see it has 2 numbers touching it exactly. So we multiply these together to get to 451,490, and we add those 2 values together. So here is my implementation of that. Pretty much what I've done is I've gone through the array, every row and column, and I try and look for every asterisk. To me, it makes the most sense to start with asterisks and go outwards because if you start with an asterisk, you can check all around it. Whereas if you look for the right number and then look for the asterisk, you would have to do some sort of like graph traversal to go to only one and make sure that from this number you can reach 1 star and exactly 1 other number, which I feel like would be a bit harder. So yeah, what I've done is look for every asterisk, and then I have this get gear value function, which is another recursive function. And what we do is we check every possible direction from the asterisk. So starting in the top left, you can see I have this directions array up here. So yeah, we pretty much check every single adjacent element. Oh, got a cheeky print statement there. And if it's a number, what we do is, so for example, in this one here, we'll start and we'll look at 7 here, and we see 7 is a number. So we go into this get gear value, we go into this get gear number function, and pretty much we check the number on the right of it, we check the number 2 on the right of it, and we check the number on the left of it, and we check the number 2 on the left of it. So in this case, we get this number 7, and we know 6 is on the left of it, 4 is on 2 left of it, and there's nothing on the right of it. And then what I did is I pretty much just combined all these strings together, you can see here. And yeah, so what this does is it recursively, so the first thing it does is look in the top left, it'll find a digit, and then it'll find what's connected to that digit. So in this case, we'll find the total 467. Then it will recursively call the function again, but in the second recursive call, it stored this 467 value, and now the input, this 467 value will be blank. So then we can't find it again, because you can see in the case here, if it found 3 first, if we don't remove this 5 value, then later on it will find 5 again, and then it would double counter, or it wouldn't be touching exactly 2 numbers, so it wouldn't be counted at all. So yeah, we have this pretty poorly coded. There's definitely got to be a better way to do this, but we have this recursive function. Then yeah, just sums everything up, gets you the answer. Thanks for watching.